Good evening, respected dignitaries, faculty members, and delightful audience. I, Sujal Deshmukh, feel privileged to welcome you all to the Engineers Day celebration at LIT University. We have gathered here today to honor the invaluable contributions of our engineers to society and nation. Initiating the event, I request all the dignitaries to please pay the floral tribute to the two eminent personalities whose vision, leadership continue to inspire our future generations. Rao Bahadur Lakshmi Narayan sir and Mokshagundam Vishwasaraya sir. I request everyone to please rise in the respect of Vidyapit Day.
विज्ञानं विजयताम् विज्ञानं विजयताम् विज्ञानं विजयताम् विज्ञानं विजयताम् सुरन्द्रनवभारते नवीनं सुरन्द्रनवभारते नवीनं विज्ञानं विजयताम् विज्ञानं विजयताम् विज्ञानं गूढरहस्ये आकाशस्थं वायुवन्यजलं पृथिवीतस्थं परमऋषीणां यदृदयस्थं तत्साक्षात् पूर्वता विज्ञानं विजयताम् विज्ञानं सुखं विहरतां चन्द्रमण्डले सञ्चरतां तारामण्डले भूगोलं पश्यतां गगने योगिजनापि च मत्पूर्वकं विज्ञानं विजयताम् विज्ञानं विजयताम् यन्त्रशक्तिमत्यन्तमद्भुता वेगितशक्तिं जलगणनीतां परमां शक्तिं परमाणुगतं विश्वहितार्थे विनियोजयताम् सुतन्द्रनवभारते नवीनं सुतन्द्रनवभारते नवीनं विज्ञानं विजयताम् विज्ञानं विजयताम् विज्ञानं विजयताम् विजयताम्
Thank you everyone. Now, for welcoming our esteemed dignitaries, I would like to ask Dr. N. Patil sir to please present a floral welcome to Dr. Atul Vaidya sir, Vice Chancellor, LIT University, Nagpur. I would like to ask Dr. N. Patil sir to give a floral welcome to Dr. Neeraj Katti sir, Registrar, LIT University. So please be there, as I would like to give you the privilege to welcome Dr. Bharat Banwasi sir, Dean, School of Chemical Engineering, Light University, Nagpur. Sir, I would like to give you the privilege again to honor the welcome of Dr. Jain Modak sir, Dean, School of Chemical Technology. Now, I would like to call upon Dr. Mayu Yanki sir, Faculty Coordinator, to welcome Dr. Ellen Patil sir, Director, Board of Students Development. Now, I would like to give the privilege to Mr. Sahil Malecha, Student Coordinator, to give a floral welcome to Dr. Saurabh Joglekar sir, Faculty Coordinator. Now, moving forward to an insightful session to expand our knowledge bases as the recent advancement of our field, I would like to call upon Mr. Sahil Valecha and Mr. Sarvesh Saha to give an insightful presentation on the topic recent advancement in chemical engineering and technology.
Hello. A very good evening to everyone present. I am Suresh Shah from third year. A very good evening to everyone present. I am Sarvesh Shah from third year, and today, on this auspicious occasion of Engineers Day, I'll present before you a presentation we prepared on the recent trends in chemical engineering. Next slide. So, a few of the major breakthroughs in the world of chemical engineering in the past year or two have been sustainability and green engineering. We'll see that in detail. Advanced materials, for example, there's nanotechnology and catalysis. We always strive for faster processes in our industry. Digitalization, AI, markup language, automation. AI is on the rise right now. We'll see that in detail too. Hydrogen economy, clean fuels, the process intensification and novel reactors, designs, waste valorization, and circular economy, regulatory, ethical, and social considerations. All these over the past 2 or 3 years have been on the rise in debates on the recent advancements in chemical engineering. Next slide, please. So first we look at sustainability and green engineering. Sustainability means nothing but to fulfill our needs for now, but also keep something for the future generations incoming. Also, a few things developed are bio-based feedstocks and biodegradable materials. That is when we use food material instead of fossil-derived fuels because there is only a finite amount of it. Then we have carbon capture utilization, where we capture carbon dioxide and convert it into useful chemicals. Then we have plastic and chemical recycling. So we convert already waste plastics into monomers. And there's also green solvents, solvent-free reactions, water-based systems, also called as mechanochemistry. All these can be derived from the 12 principles of green chemistry, such as atom economy, zero waste technology, which we have all studied in previous sections. Next slide, please. Then we also have digitalization. As we all know, AI is on the rise. Some things which the human brain cannot comprehend can be done in a minute with AI. Complex equations, complex derivations, etc., which we take a while to do, can be done in a minute with artificial intelligence. So it can be used for many things in chemical engineering, such as process optimization, in production of different chemicals, in production of different products, etc. A few things are it can be used for process optimization, as I said, for predictive modeling and controlling of different processes, for digital twins for plants to simulate and monitor in real time and make operations more reliable. Physics constrained markup language, which blends physics models with data-driven ones to improve reliability. We all strive for more accurate results in engineers. So we always So as AI is on the rise, we are trying to use it and integrate in our processes. Then we have multi-agent systems, which is generative AI for designing process flowing and instrumentation diagrams automatically. As I said earlier, humans are trying to minimize the workload, so AI can take the lead. Next slide, please. So these are few of the case studies which have been on the rise in the past few years. For example, e-methanol plant in Denmark has been on the rise. It uses renewable energy and captures carbon dioxide to produce low emission liquid fuel and reduces emission by a massive 95%. Then IIT Hyderabad has made biodegradable packaging film. It is made from sewage sludge and eggshells. It has improved mechanical and water barrier properties. So, for example, in food technology, as we see, food products need packaging, and therefore these are the new packaging that are coming through. Then metal nanoparticle formation by confined duetting. IISCR Pune and IIT Bombay has done this for disease detection and sensors, giving uniform and stable nanoparticles. The making of nanoparticles is in itself a very difficult thing. The size of nanoparticles, as we know, is quite small, and therefore predicting it on how it will perform, how it will see, is very hard for naked eye to observe. Then there's automatic AI framework for auto-generating process and instrumentation diagrams, PFDs and PIDs using physics-aware generative AI, improving feasibility or speed from lab to industrial scale. As I said earlier, AI is being used to speed up our processes and more. Next slide, please. And a few of the future things that have been projected to come in the next few years are the rise of AI, as I said earlier, AI and markup language, and multi-agent systems in design, control, safety of different processes. Greater use of renewable energy, such as green chemistry, the principles of green chemistry to be applied further in the world of chemical engineering, more decentralized and modular chemical production, advances in synthetic biology, biocatalysis to produce chemicals or fuels with fewer harmful byproducts. More circular economy, which is full life cycle design. So recycling will be a bigger subject in the world of chemical engineering. And policy incentives such as carbon taxes, stricter emission norms, subsidies for clean tech will push faster change. So, in summary, chemical engineering in the past years has seen a lot of development with the use of AI, green chemistry, and many other topics. Next slide. Thank you.
Thank you so much, Sarvesh, for that insightful presentation. I'm sure that each one of us has got something that we can work upon. Now, I would like to call upon Dr. Bharat Banwase sir, Dean, School of Chemical Engineering, to please share his thoughts.
Good evening. First of all, I wish all happy engineers here. Respected Honorable Vice Chancellor Sir, Registrar Sir, Patil Sir, my colleague Modak Sir, Jogrekar Sir, my faculty colleague and students. Today we have gathered here for celebrating Engineers Day. So, day dedicated to honoring and vision and legacy of Sir Bharat Ratna Sir Vishweshwarya. His life works remind us that engineering is much more than the machine, than processes, formulas. At heart, it will be about solving the problems of society and shaping the future of the humanity. As a student of chemical engineering and chemical technology, if you see forward, sustainable development, what he has presented, and what is the future for chemical engineering. No doubt, whatever changes are taking place, that is the process intensification, that means whatever research and development is improvement in rate of chemical engineering, chemical reaction, improvement in rate of mass transfer, heat transfer. So that is what expected, so that at the same time minimization of waste and energy optimization. So at the same time, we have problem of climate change, that is resource scarcity, then environmental remediation. Many times we are discussing of how we can recover the material, valuable materials from the waste, because anyway it is going in drains. Once it is used, it is going to waste. Because someday we have to think about this. That is how we can recover and whatever engineering or technology, what you can do about this. So this is another important thing. So we have to see the solution for this, and by advancing the research, innovation, and all these things. So based on this, what I can say today, we are celebrating and we should encourage our young engineers, because today, no doubt, innovation, hard work, it is everything is okay, but we should have multiple talents with you. When you are working in industry, I think you should have additional weapons with you. And you should work on that. That means whenever you are doing your engineering or technology, I think we should learn so many things which are important, what we are seeing today, AI, ML and all these things. So that is very important. So for this, I think you should be curious, right? So we should think what is going on, what I can do about this. So that is very important thing, and you have to see your idea how you can implement those. So that is again very important. Then be responsible, because when you are becoming engineer, because you are developing, you are designing, and that should not create problem for humans. And so whatever we are saying, solar industry, so explosion and so on. So you have to handle all these things carefully. That means when you are designing, because you are dealing with hazardous chemicals and so many things. So you should be responsible for that. And one more thing, so that is you should be innovative. And for that, always think about creation and see the new things what you can do about, right? Develop those, try to implement at industrial level, right? And once you are in industry, that is the difference from others that you will get. Okay, so happy Engineers Day and thank you.
Thank you so much, sir, for your valuable insights. Now, I would like to hand over the mic and podium to Dr. James Modak, sir, Dean School of Chemical Engineering, School of Chemical Technology, to address the gathering.
Good afternoon and very happy Engineers Day to all of you. Honorable Vice Chancellor, sir, all the statutory officers, faculty members, and all my budding engineer friends. So we celebrate this Engineers Day to remember the significant contributions by Sir Moksha Gundam Vishweshwari. Why this is so? He is known as the father of Indian engineering. I can tell you few examples. Mysore Dam, very famous dam, that came out of his vision. You will say, what's the difference in this dam? Single dam caters water for irrigation, drinking purpose, and hydropower generation. So that too in that area. This time it is very easy, but that time it was very difficult, and it is constructed of soil, no cement, gravels, etc. So that was the vision, and I can tell a few more examples on the basis of that explains his style of working. He was traveling by train. See, that time also he was thinking from engineer's point of view. He noticed change in the noise. He immediately asked the loco pilot to stop the train by applying emergency brake. Later on, the reason was noticed that crack in the track that could have led to derailment of the train. So he saved that train. Once he was at a railway crossing, see how he expects the engineers to perform. Railway crossing, there was a person who used to clean the railway crossings. Nowadays, all are converted into underpass, but that time there were so many railway crossings. When the train passes, the gate was closed. And on the same, in that particular area, the vehicles also pass. So the gap between the tracks gets bridged. So it needs to be cleaned every time. So what he said, remember, man, cleaning the railway crossing might be your way. Only cleaning the railway crossing might be your work. But if you can keep it as clean as possible, that no other railway crossing in the world is as clean as yours. What this takes? Commitment, dedication. So whatever we do, we should do it with total commitment and dedication. We should always strive for excellence. We always tell these student friends to behave like engineer. Many times I notice indisciplined behavior. क्लास में लेट आना, प्रैक्टिकल में लेट आना. तो हम बोलते हैं कि यार ये इंजीनियर की क्वालिटी नहीं है. You should not give any excuse. Be on time, be perfect every time. Right? So we should always strive for excellence, and we should always inculcate in ourselves the qualities of engineers. I can quote few examples of indiscipline. We had a program of Model United Nations, and what we saw, students were traveling wrong side on bike at 666. What we expect during Ganesh festival, do not purchase ready-made Ganesh idol. Create out of the things available in our premises. Don't dance with DJ. Let us go for some creativity, some innovation. Because that is what expected. You have to perform on these lines in your future. Then only you can progress, you can succeed. Because successful people do not do different things. They do the things differently. So you have to think from this point of view. Always keep this in mind. Whatever you do with excellence, do with some different creativity, innovation. Then definitely you will succeed in your life. Thank you. Thank you.
Thank you, sir, for your motivating words. I would like to call upon our esteemed Vice Chancellor, Dr. Atul Venkya, sir, to grace us with his words of wisdom.
Very good afternoon. Engineering problem, right? There are many engineering problems in our audio systems. We have to repair each and everything. Happy Engineers Day to all. We celebrate Engineers Day as everybody has already narrated. It's the birthday of a great engineer of India, Mokshagundam Vishweshwaraya, born in 1860. Probably graduated in 1880s from College of Engineering, Pune. Second oldest engineering college of India. First one is in Roorkee. You should know as engineer. Somewhere established in 1850 and then 1860s, COEP Pune was established. Vishweshwaraya was alumnus of COEP. He was a very ordinary, he was a person from very ordinary, simple family. But very brilliant. Used to walk 15 kilometers for his schooling and all education. So we complain this is not there, that is not there. So all these things are on revisions. A genius will never complain about the circumstances and the conditions in which he gets education. Of course, he passed out his graduation in flying colors and immediately was appointed by then Bombay government as assistant engineer at that time. He was already famous as a student also. And if you read his credentials, first time name, maybe it is Hyderabad flood conditions, maybe it is Mysore Dam, Vrindavan Garden, everybody has seen. Rarely we remember who has created that garden. Based on everything, only on the one dam, as Modak sir said, 3-4 things in one dam. He has done many engineering marvels in India single-handedly. There is a list of his, and he was a doer first time. Something created on ground so people can watch as a monument, not theory, not obligations. not patents. Actually, the thing today also you can go to Mysore and see and appreciate his creation of Vrindavan through Vrindavan Garden of Krishna Sakara. And most important, that most disciplined person throughout his life, he lived for 102 years. And he said that because I had to walk a lot in school, so that kept me very healthy throughout my life. And extremely honest and ethical person. That is the most important virtue any student or any engineer should have. Honesty and dedication, integrity. So much so that, of course, he was heading many offices. He used to sign many checks in those days. If check was official, he used to carry 2 pens in his pocket. For official purpose, he will use official pen. But if that check is for his personal purpose, for anything to be written for personal purpose, he will use another pen. That is the level of integrity, that is the level of honesty, Imandari. And therefore, despite doing crores of projects in modern terminology, Vishweshwaraya was Vishweshwaraya. He never had his palaces built. Even he was called for international problem in Red Sea. There was some problem in the Red Sea about that time British government, and he was referred by British government. He is the person who can resolve that issue, and he resolved it. So likewise, there are many credentials to Vishweshwaraya. Nagpur should be proud that our then regional college, now NIT, BNIT, is named after Vishweshwaraya. It was VRC earlier. To honor Vishweshwaraya. He was the engineer by profession, by heart, by thinking. We have to be like that. At least we try to imitate it. We try to copy 1% of him. All of us, if we are around 1% of what Vishweshwaraya was, I think the super golden age for India is not away. Unfortunately, we even don't know him and we don't try to imitate. We have all other equations. So that is a different issue. What I want to say, try to understand what is engineering. You have to create it. You have to show something to the world. This is my creation. A chemical engineer has to show a plant. If you are advocating sustainability, you have to show it is sustainable. For which you should know what is sustainability. If you are, I saw a few case studies referred. If a good chemical engineer will not believe, question how something is biodegradable, something is sustainable. Merely Atul says this is sustainable, you don't believe. Any student of chemical engineering should not believe. He should ask basic questions, and those basic questions you should know. What is to be asked for checking what is sustainability, what is circular economy, what is greening, what are the, somebody referred 12 principles of green chemistry. Anybody knows which is the first book written on green chemistry, by whom? Any student has read that book? What is the book on the green chemistry written by whom? Internet पे सब मिल जाता है, but you will not get the book. ये कभी एनास्टस करके एक साइंटिस्ट था, उसकी किताब है ग्रीन केमिस्ट्री प्रिंसिपल्स, पढ़िए. And if atom economy is the principle of green chemistry, you must know atom. Just by saying atom economy. So go through the principles while you say those things. I'll be very happy if you come to me or come discuss with your faculty about the basics. I have a lot of presentations out right now. I can show you what chemical engineers should ask about sustainability in green economy. There is no time because we are celebrating Engineers Day. But a chemical engineer will be a most valued customer, most valued professional If you have to look for the sustainability, if you have to look for the circular economy, if you have to look for greening of the processes and technologies, or anything like that. If you are a thorough chemical engineer, you will be the most valued professional. If you are really thorough, for which you have to be expert in science, technology, engineering, everything. And engineer is not supposed to stop at science, not to stop at engineering, but he has to reach to the technology level, which has commercial aspects, which has scale aspects, and which is for the general human purpose and human comfort. Otherwise, he is no engineer or not technologist. Merely showing something in laboratory is not technology, that is of no use. It's only good for publication patents. That I'm very frankly telling you. Because I have been sitting in many committees where I have to differentiate between processes and engineering and the technology. That is the yardstick everybody applies for. So try to be a good engineer, first thing. So to be a good engineer, you must be a good scientist first. You must be good engineer, then you can become very good technologist. So your job is threefold. And remember, persons like Vishweshwar, try to read about his biography. There are many engineers in India. So reading such things will keep you on track. Modak sir rightly said discipline is the most important. What we do instead of doing engineer, we spend a lot of energy in moving around the campus, spoiling the campus, asking for your rights without really looking for the responsibilities. The example he put is very right. Anybody would have watched that from outside. So that program was very good, appreciated everywhere, but simultaneously there will be some people watching you. What kind of discipline will your students have or other students have? See the way you roam in the campus. All these things matter if you want to be, because the discipline, engineering is a discipline. A single point here and there, a bridge can collapse or industry can fail. So discipline is, there is no substitute to discipline, there is no substitute to knowledge. We have to learn all these things from such people like Vishweshwar on this day. Remember that. And try to understand like who was the first engineer. We have to apply our mind. Don't get into the mythology in this. What two principles I will just quote and end. Who was the first engineer of India? Mythologically say whatever it is, Bhagirath. What he did? Mythologically we say Bhagirath ke piche piche Ganga hai. What do you mean by that? Story मालूम है सबको. So Ganga was not ready to come on earth. Why? Reason given was she said earth cannot sustain the speed at which I will enter on the earth. अभी आपने देखा है, अभी थोड़ी देर पहले बिजली कड़क गई थी. Must have touched around Gravity Tower. What is the voltage of that lightning? Anybody? Millions of those. 10 lakhs, minimum 10 lakhs. See how much energy. Probably to light Nagpur for whole year, most probably. You cannot do anything. So waste. Because in a fraction of second you cannot calculate. Same was the problem with Ganga. If Ganga had come like that speed on the earth, nothing for the use of earth would have been possible. What Bhagirath did is that he actually, right from Gangotri to Gangasagar, it was a kind of preparation of canal through which Ganga will flow at a very useful rate, useful for human being, not destroying people, not causing any havoc. So that is the engineering. So forget about Bhagirath and Ganga and mythology. What engineer has to do, that is a very good example. It is for human comfort, it is for human life, it is for all. So engineer has to be inclusive, engineer has to have a human value, and engineer has to do something for the humanity and comfort of the humanity. So try to be a good engineer, try to understand the basic principles. I wish you all the best, and probably on next Engineers Day we will have some better things to present here. Right? I'm not saying this was a bad presentation. I am saying your creations. You create something in 1 year, some model, something, so that your engineering acumen will be appreciated or it will be displayed. With this, I end here. Thank you very much. All the best.
Thank you so much, sir, for your so insightful address. Making the celebration of Engineers Day more memorable, I would request everyone to please stand for the Engineers Oath. I request everyone to please repeat after me. By the blessing of M. Visvesvaraya, sir, I am an engineer and I pledge to dedicate my knowledge, skills, and efforts for the progress of society and nation. I will work with honesty, discipline, perseverance, and innovation, keeping the welfare of humanity at the heart of all I do. I commit to the upholding of values, responsibility, excellence, and to contribute meaningfully toward building a better and sustainable future. Thank you. Now, I would like to invite Dr. Saurabh Jubliga, sir, faculty coordinator, to present a formal vote of thanks.
Thank you. To begin with, we were discussing with Honorable Vice Chancellor sir about what kind of activities are to be performed on the eve of Engineers Day. So a thought came to my mind that let us have a presentation made by the students so that the students can come to know some pointers where they can see where the technology is going. And all of us are engineers, are budding engineers. We would like to have some pointers where we think we will be able to contribute. So that was the whole thought of putting a presentation, as rightly said, sir. Next year, maybe we will also try to keep some model presentations where students can showcase their inventions. To propose a formal vote of thanks, I would like to thank Honorable Vice Chancellor, sir, for his words of wisdom. So your encouragement is very important and it brings us the best in all of us. I would also like to thank Registrar Sir, Dr. Kati Sir. I would like to thank Dean School of Chemical Engineering, Dr. Bhanu Seth, Dean School of Chemical Technology, Dr. Moda. We were also having a discussion about the whole plan of execution of this project, of this event. Thank you so much, sir, for accepting our request to guide the students. I would also like to thank Directors, Board of Student Development, Dr. Patil sir. I'd like to thank all the faculty members who have come. I know we started quite late, and it is the end of the working day. So I thank all the faculty members and to all the students. Thank you so much for coming down here. Also, a special appreciation to the student coordinators, Sahil Valecha, Sujal Deshmukh, Abhishek Gold, Naneshwari Atmane. All these students, actually we started preparation for this on a Saturday. I didn't realize that Saturday was a holiday, so I thought I'll do all the preparations on Saturday. But since it was a holiday, we did everything on call. And kudos to you, good job. Thank you so much for coming down here, and let's hope the next year we would have a better event where we can showcase all the activities. A lot of faculties have been working in really very innovative areas of work. I would request all the faculty members also to contribute next year so that we can prove to be a source of inspiration for the students to take up all these activities so that it is in the benefit of our students as well as of our university. So, thank you so much, sir. With this, I conclude the event and thank you so much.